All right, folks. Well, welcome back. Hopefully, you were able to watch the videos yesterday and be able to get the work done there. Please make sure you come by after school. So, if you noticed, I've posted on Classroom that there was a change in the office hours. So, right after this period here, come on by and check and check in and ask your questions then. Okay. All right. Um, let's go ahead then. We left off with this discussion about how we can uh, visualize motion by plotting the motion on a graph. Okay, so we can plot how an object moves on a graph. We were able to interpret two position time graphs yesterday. Okay, and so what you have to be able to do then is you need to be able to take the information from a position time graph and interpret how the object is moving. And so this is one way that we can represent motion. So you got to make sure then that what we're trying to do here is we're trying to represent motion in a number of different ways. Today, what we're going to do is we're going to start talking about how we can represent motion from a formula and how we can use that formula then to predict motion, because that's the end goal for physics for the most part, and I think for much of the physical sciences, and I think for part of the biological sciences as well, and that is we want to be able to take what we observe, find patterns in it, and then from those patterns be able to make predictions as to what will happen if there's some changes that occur. And so what we're doing here on the most basic level is we are practicing that and using motion as a way to teach you that. Okay, so here what we can do then, and we'll interpret this graph here in just a moment. I'll ask you some questions, and then I'll ask that you answer the questions on Edpuzzle. But you have to be able to interpret it, and then, like I said, we're going to talk about how we can use this information here to predict motion as well. Okay. Right, so what I want us to do here then is I'm going to ask you a series of questions, and then I will pause the video for you. And then what I want you to do is answer the questions on your paper, and also make sure you type in your answers on Edpuzzle as well, okay, regarding this particular position time graph. So here we have a position time graph. Well, there are two objects that are indicated here. Okay, so two runners, okay, two people that are running. We have Juanita and Heather. Okay, so I'm going to ask you some questions about their motion. And you need to be able to describe this, okay, from the information given to you on this position time graph. Okay. All right, so let's get started. Let's get started here. The first question I want you to answer on Edpuzzle and on your paper is this. Okay. What happens at t equals 0 seconds? Okay, so go ahead and answer that question. All right. Second question. When does Heather start? Third question, do the two start at the same place? Okay. Fourth question, will Heather ever catch Juanita? And then fifth question, how do you know? Okay, so hopefully you had a chance to answer all those questions. And again, like I said, make sure you have it written down on your paper, but let's go ahead and let's go through and answer each one of those questions together, okay? All right. So make sure you write down, if you didn't get the answers to this, and let's for the 5 questions I asked you, make sure you write them down now. Okay. So here is a position time graph representing the movement of two objects, Juanita and Heather. Okay. Positions always plotted along the y, and time here along the x. Okay. Position, the units are in kilometers here. This is how far they move in kilometers, and this is the time interval that they move in. Okay. All right, so let's go ahead then and let's answer the first question. Okay. What happens at time equals 0 seconds? Well, when t is equal to 0 seconds, when t is equal to 0 seconds, it's at this point right here. This along the x-axis, time is right here. And what do we notice happening? Juanita starts. Juanita starts moving at t equals 1 second. So Juanita starts to move. She starts her run. So Juanita starts to run at t equals to 0 seconds. So when you start the time, Juanita's there, she starts to run at time is equal to 0 seconds. So Juanita starts her run at that point. Okay, so that's the answer to question number 1. Okay. All right. Question number 2 then is, if Juanita starts at 0 seconds, when you start the time, does Heather start at the same time? And the answer here is no. So if you take a look at when, not where. Now the question number 2 is asking about when Heather starts. Heather waits. There is a delay of about 1/10 of an hour. So you have here then 1/10 of an hour. If you have 1, 2, 3, 4, 1/10 of an hour. Okay, and so Heather starts about 10 minutes after. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 10 minutes after Juanita starts. Okay, so when does Heather start? Heather starts at T is equal to, and if you want to write this down, 0.10 hours after Juanita. So they do not start at the same time. Based upon this graph here, they do not start at the same time. Okay, so make sure you keep that in mind. Okay. Now the question is, do the two start at the same place? Okay, so do the two start at the same place? Now this is a tricky question here that it's probably a little unfair to ask you, Kim. And that is we don't know. Okay, well, I'm sorry. That is we from the graph, and so let me backtrack here. So from the graph, then they both start at position 0. So from the position time graph, we see then that they both start at the 0 pointer. So I'm sorry. We do know then that they start at the same place. So number 3, they start at x is equal to 0 kilometers. So they start at the same place, but they do not start at the same time. Okay. Now, when we go to other graphs, and this is where things get a little bit tricky, make sure you understand that when we start talking about velocity time graphs, okay, that question cannot be answered. But here we have a position time graph, okay, and so we see then that they both start at the origin here at 0, and they move out from there. Okay. All right. Question number 4. Will Heather ever catch Juanita? So Juanita starts first at 0, and then Heather starts out. The question: will they ever start? Okay. Will they ever meet? That is, will Heather ever catch Juanita? Okay. The answer here is no. Okay. So no, Heather will never catch Juanita. Okay. And we'll see that in just a moment when we calculate for velocity. Okay. But what you'll notice here then is the one graphical clue that we can use is to determine then whether the two objects or the objects that are depicted on the position time graph, if they ever meet, is if the lines intersect. If the lines intersect, then they meet at that given moment in time and the given moment in space. Okay? But if you notice here, the graph for Juanita and the line for Heather, they will never intersect. They never intersect. They never cross each other. So these two will never meet. Okay. And so how do we know? So the answer number 5 then, how do we know then that they never meet? The lines don't cross. The lines do not cross. So the lines do not cross. Okay. All right. So those are the answers to the 5 questions I asked you. So make sure you come by and see me if you are having some trouble with this, but that's how we know from the graph. Okay. All right. So hopefully you get that down. What I'd like to do then is let's go ahead and let me erase the screen here. Okay. And let's consider what we have here. Okay. So let's focus in on Juanita first. Okay. And then we'll talk about Heather here. Okay. So I want to ask you this quick question. The slope for this line, the slope that represents Juanita's line. So the slope then we can indicate by the letter M. Remember, the slope then is represented by the change in y over the change in x, or what you've learned also is the rise over the run. Okay. Rise over the run. Okay. Now, what I'd like you to do is to really quickly consider then what are the units? What are the units associated with this slope here? Okay, well, the y units are kilometers, and so let's do a quick dimensional analysis. Or dimensional analysis simply means that analyzing units. Okay, partly. Okay, so the units for y are kilometers, which is unit of length, so it's kilometers, over unit of time, which is on the x. Kilometers over hours. Now, if you take a look at those units, and we've talked about this already, this is length over time. So this represents a unit of speed. Just think miles per hour. Okay, this is kilometers per hour. So what we have here is how fast Juanita. The slope of the line then represents how fast Juanita is running compared to what Heather is here. Okay, so if you notice here, the slope for Juanita, is steeper than the slope for Heather, meaning then her change in position over a given time interval is greater than that of Heather's. What does that what does that translate through to? Juanita is running faster than Heather. So that's another reason how we know then that Heather will never catch Juanita, because first of all, Juanita starts out first and then she's running faster. And so with that said, then the slope of the line also gives us the indication. So the lines don't meet, but furthermore, the slope of the line here, Juanita is moving faster than Heather. Okay. So how would we calculate the slope then? How would we calculate the speed then? Just like you've done before. Pick 2 points on the line here. Let's go ahead and pick 2 points here, and you got remember you got to have 2 points on the line in order to calculate the speed. Okay. All right. So with that said, let's go ahead and calculate for Juanita's speed here. So her slope then, or the speed then is going to be. So let's take a look at the coordinates here. We have then. This is about a fourth of an hour, sorry. And this is about a sixth of an hour. Okay, so the coordinates for this first point here is going to be let me go ahead and erase that quickly. The coordinates here, so we can work that out. It's going to be 0.4 and 2. The coordinates for the second point here is going to be 0.6 and 3. Okay, so let's go ahead and solve for the speed then, which is the slope for this line then. And so we'll call this 0.2 and we'll call this 0.1. Okay, so the change in y then is going to be 3 minus 2 kilometers minus 2 kilometers. Okay, over the change in time, which is going to be 0.6 hours minus 0.4 hours. Let's go ahead and plug that in. That's going to be 1 kilometer, and that's going to be 1 hour. Okay, so 0.6. Let's go ahead and let me just check something really quickly here. 6. Okay. So that means then, if we take a look at the slope, the speed at which Juanita is running then is going to be at a rate of 1 kilometer per hour. So that is her speed. Okay. So you can go ahead and calculate for Heather's speed as well. And so what I would like you to do then is real quick on your paper, please calculate for Heather's speed. So go ahead, calculate for the slope of this particular line here. Write it down on your paper, okay, and then you'll submit that as well. Okay, so make sure that go ahead and get that done. Take about a couple minutes to find the slope and thus the speed for Heather, and then make sure you input that onto Edpuzzle, and then write that on your paper. Okay, so I'll leave that up to you to do. Make sure you come by and see me if you have a question on how that's done. But make sure you then just pick 2 points on the slope for Heather here and calculate for this particular slope. So just pick 2 points and calculate for that slope. Okay. Okay. Hopefully, so good job. Hopefully you got that done okay. Let's go ahead then. Let's continue on. Okay. And let's take a look at what this slope means. So the slope then is, again, what we talked about then is the change in the vertical, rise over the run, change in vertical over the change in x, change in y. And so that means then from the position time graph, we are calculating for the change in displacement over the change in time. And the units then will be length over length per unit of time, which is going to be the units for velocity. Okay? And essentially what we're calculating here is for the average velocity over a given time interval. So make sure you understand then this represents the average velocity, which means that over that given time interval, this is roughly how fast a particular object is going to move. Okay, so I want you to make sure you keep that in mind. Okay. All right. And so with that said, then the direction, velocity is a vector quantity, which means we have to also indicate direction. However, from our calculation, we should be able to see then whether the object is speeding up or slowing down. Okay. I'm sorry. From our calculation, we could make that determination, but from the slope that we can see then the direction of the object and the direction it's moving, either positive or negative. Remember, this is along a straight line. And then we can calculate for that. In our calculation, we're going to be able to get the direction as well. Okay, so make sure you keep that in mind. Okay, and so this average velocity, remember the difference between velocity and speed. Average velocity takes only into consideration the starting point and the end point, and whereas speed has to take into consideration the total distance traveled. Okay, but what you'll notice then is with both speed and velocity, the units, the dimensions will be the same, or your length over time. The only difference then is with velocity, we have to indicate a direction. Speed, we do not. Velocity is a vector quantity. Speed is a scalar quantity. Okay. All right, so some examples of the units then that we use to describe speed: meters per second or centimeters per second, kilometers per hour, miles per hour. So those are some units that we use to describe speed and velocity. Okay. All right, so let's really quickly then, let's take a look at how we would calculate for velocity if we don't have the graph, but we're given information about displacement and we're given information about time. Okay, so on this representation here, what you'll notice then is that we are given information. We were given information about the displacement. Okay, so the object here, the race car, starts out at a position of 10 meters away from the origin, ends up at a position that is 60 meters away. We did this already. The displacement then is going to be in the positive direction at 50 meters. What we've also included here is a graph for time, which means then that the driver starts at times equal to 0. That's when we start him. And then by the time he gets to 60 seconds, he's roughly, by the time he gets to 60 meters, he's gone roughly about 50 seconds. Okay, so if we take a look at this then, okay, if we take a look at this, scroll this down for you. If he moved a total distance of 50 meters, okay, total displacement of 50 meters, and he did that in a roughly about a 50-second time interval, okay, his velocity, his speed then is going to be 1.04 roughly meters per second. That's the speed, no indication of direction. However, if we want to indicate that this is a velocity, then the race car driver has moved in the positive direction, and his velocity is then also in the positive direction. And so if you want to keep this in mind, the direction of the velocity and the direction of the displacement will always be the same. So if the displacement is in the positive direction, the velocity will also be in the positive direction. If the displacement is in the negative direction, the velocity will always also be in the negative direction. So the direction of the displacement and the direction of the velocity will always be the same. Okay, so make sure you keep that in mind. That's going to help. Okay, because let's take a look at the next example here, and we can see the same thing. Initial position then, the race car driver starts at a position 70 meters away from the origin, and then he moves to a position that's only 30 meters away from the origin. So therefore, his displacement is going to be negative 40. Okay, negative 40. So with that said then, there's the displacement in the negative direction. Okay, now keep in mind then, I just told you displacement and velocity, those two vector quantities will always be in the same direction. So there's what we have. Okay. All right, so with that said then, we have the time scale given to you above that. He starts out at 0 here, and 40 seconds later, he ends up at a position of 30 meters. So he moves the total time interval. His time interval that we are examining this motion is 40 seconds. So therefore, his velocity then is going to be a negative 1 meter per second. Okay, so there it is. The velocity is negative, okay, and the displacement is negative. The speed, though, if we're going to describe the speed, remember, is a scalar quantity, and so the speed then is simply going to be 1 meter per second. So basically, we take the absolute value of velocity here, we get the speed. So velocity has direction, speed does not. Okay, so make sure you keep that in mind. Okay. All right. Let's go ahead then and let's try a problem. Okay. So here, let's go ahead and I'm going to write this down for you. So basically what we know so far now is that if we know what the velocity is, okay, so we can define the velocity then as the displacement per unit of time. That is the displacement over a given time interval. Okay. Speed is also described in much the same way, but speed is not a vector quantity, it's a scalar quantity. So therefore, we also have the total distance over the total time interval. Okay, so what we were given here, so we can use this to help us solve for problems involving speed, displacement, or time. Okay, let's take a look at what we have here. Okay, let's take a look at this problem here, and let's analyze what we were given. Okay, so we are told then that we have a bike moving at this speed. Now, if they don't tell you that it's speed, you can look at the units here and make that reach that conclusion as well, because the units here are meters per second, length over time. This is a speed. Okay, those are the units of speed, and we're given time here. Okay, so like I told you, we can use then these equations that we derive. So again, this equation we were able to derive from the position time graph, because the speed and the velocity is basically the slope of that line. So the line on a position time graph gave us this particular formula. What can we do with this particular formula? Well, if we know the speed then, if we know the speed or if we know the velocity, we can predict how long an object takes to cover a certain distance, or how far an object will move over a certain time interval. We can make that prediction. So that's what they're asking us to do here. They're asking us to predict then that if the object, the bike, is moving at this speed here, and he moves for this long, okay, how far will he end up? Okay, so let's go ahead and let's real quick plug that in and solve for it, and then I'll finish up here for you. Okay, so how would we solve for this one here? So which one are we solving for? Okay, so let's go ahead. What I would always suggest you do when you work out these problems, write down the formula that you're going to use. Okay, so this is the formula for velocity. This is the formula for speed. So obviously, since this problem is indicating speed, we're going to use this formula right here. Okay, so let's go ahead and use that one. Then what I would suggest you do is write down what you're given. Okay, so you're given then. This here really quickly. Okay, you're given then speed. Let's go ahead and write that down. So speed then is given to us as 4 meters per second. Okay, what else are we given? We're given time, and this represents the time interval. So this is not the start or the time, the end time. This is the total time interval for 5 seconds. And so you'll have to recognize then that unless they specify starting time and finish time, which would be T initial, T final, you can always assume that what they give you is going to be the time interval. Okay, and so what are they asking to solve for? They're asking us to solve for the total distance that it travels. Okay. So at this point then, what I would do, and what I would suggest you do, especially for you folks who are going on to physics, is that take the formula here that you're going to use and rearrange it to come up with the equation that you will need to solve for this unknown. So hopefully you notice here, we're going to isolate delta x here. So in order to do so, we're going to multiply both sides by delta t. And if we do so, we end up with this equation right here. So from this formula that describes speed, we come up with this equation here that will allow us to solve for delta x, which is the displacement. Okay? So this is what I would suggest you do. So you isolate what you're going to solve for. At this point, folks, it's just a matter of plugging in the values and solving for it. So for the displacement, the total distance traveled here, it's going to be speed, which is 4 meters per second. Go ahead and write that in. Okay, and we're going to multiply that by the time interval, which is 5 seconds. Okay, and if you notice here, the unit of seconds going to cancel out. We end up with the unit of length in meters, and so we end up with an answer that is going to be 20 meters. 2 significant figures for those of you who are, for the rest of you, don't worry about significant figures right now, but for those of you who are familiar with it, we got 2 significant figures here because we start out with 2 here and 2 here. So you can write it in expanded form or in scientific notation, indicate then the 2 significant figures. And so there it is. There's your answer. Okay? So we have to be able to solve for problems like this, and we'll work out more problems like this tomorrow. But take a look at this problem here, and I have posted for you the lecture notes on Google Classroom. Take a look at those lecture notes, and then if you have any questions, again, comment on the Classroom or email me, or stick around after the lecture, after you watch the video today, and then ask your questions then. Okay, but we will continue this tomorrow, and you'll notice that these calculus ends up being fairly straightforward. I'll try to put together a packet for you. Unfortunately, Project Lead the Way doesn't provide us too much practice with this. I'll try to put a packet together for you to give you practice with this, and then that way is then if you have any questions, you can come by and see me. Okay? All right. Very good, folks. I will either see you in a few minutes after this video, after the period's done, or I will see you tomorrow. Okay? Very good, folks.